Alright, welcome to lesson 12.5, the last lesson in unit 12, and today we're going to talk about word problems. So your aim today is that you can use properties of quadratic functions to solve word problems and create functions using consecutive integers. So we've learned all about factoring, we've learned about looking at zeros of a function. Well, now we're going to talk about how to use those properties in terms of a real-life situation. So now that we have the zero product rule as a method for solving quadratic equations that are factorable when we set them equal to zero, we can also model situations that are quadratic in nature and solve them for those solutions when factoring. So exercise 1 is a geometry problem. It says, consider a rectangle whose area is 45 square feet. If we know the length is 1 less than twice the width, then we'd like to find the dimensions of the whole rectangle. So to start this problem, I always like to underline things. Length is 1 less than twice the width, and we know the area is 45. Okay? So letter A starts us off by saying, if we represent the width of the rectangle using the variable w, so width is w, and then it says let length be L. Let's write an expression for the length of the rectangle using only w. So that means that length, and that's going to talk about this right here. So length is, remember, is always a equal sign. How would we then translate 1 less than twice the width? Well, twice the width is like saying 2w, and 1 less than would be like saying 2w minus 1, because we're having 1 less than that. So 2w minus 1 is how I would translate that sentence. And this brings us all the way back to Unit 3. We talked about these kinds of English translations all the way back in Trimester 1 and Unit 3. Okay? The next step, now this gives us the length, but now the next step would be set up an equation that could be used to solve for the width based on the area. So what do I know about area of a rectangle? What's true about the area of a rectangle? Well, the area of a rectangle is length times width. Right? Well, I don't know my length in this case is this 2w minus 1. My width just is w. So I can take both those things and I can say, look, my area then is going to be length, which is 2w minus 1, times w. And I like to put these in parentheses to show I'm multiplying. But I know something else about the area. I know the area is what? 45. So my final equation could be 45 equals 2w minus 1 times w. So there's my final equation for my area of this rectangle. Okay, I've replaced area, length, and width with numbers and letters that represent the different parts of the rectangle. Okay, now letter C says solve. And when it says solve, the word solve means it wants you to have a length equals something and width equals something. So let's remember our product property. So I'm going to rewrite this 2w minus 1 times w equals 45. Now I remember I'm going to distribute. So I'm going to distribute the w to both of these things. In fact, let me do a favor here, because this might be a little confusing. Let me rewrite this so I have the w on the outside. Okay, so I have my w on the outside times 2w minus 1 equals 45. Okay, now I can distribute, and it might make a little more sense. So w times 2w is 2w squared, and then w times negative 1 is negative w equals 45. Now, I have to solve a quadratic, I must set it equal to 0. Okay, so to get that, I've got to get this 45 off of both sides, get that to 0. Now this will equal 0, and my left side will be 2w squared minus w minus 45. These two things, the w and the 45, there's no like terms here, so I have to write it all out individually. Now what I can do is I can use my x method to factor. So here's my x method. I'm going to get a different color pen here. So I have negative 45 and 2. That's going to give me a negative 90 on top. And I have an invisible 1 right here and a negative 1 here. Okay? So I got to think of two numbers that multiply to negative 90 and add up to negative 1. Well, I am going to instantly think of negative 10 and a positive 9. Negative 10 times 9 is negative 90, and negative 10 plus 9 is negative 1. Now I have to remember my coefficient here was a positive 2, so I divide both of these by 2. And as my factors, this factor stays 9 over 2, which becomes 2x plus 9. And this reduces to negative 5, so I get, sorry, not x, but w. Let me get my eraser here. So this should be a w. So 2w plus 9, and then w minus 5 equals 0. Now I take both of these things as my last step, and I'm going to set them equal to 0. 2w plus 9 equals 0, and w minus 5 equals 0. Okay? I'm going to solve this one first, add 5 on both sides. W equals 5 is one solution. And then solving this one, subtract 9 on both sides. 2w equals negative 9. Divide both sides by 2, and I get that w equals negative 4.5. Okay? Now, the question is asking to find length and width. So now I have two answers for what variable, just width. But we have to think for a second, because when we're thinking about geometry, this question comes up very quickly. Why is one of the solutions not viable? Viable means doesn't make sense. Which one of these solutions does not make sense? This one doesn't make sense. Can you have negative length? Can you have a shape that has negative length on it? No. So this right here is not a solution that works. So our only actual solution to this problem is the width has to be 5. So if I want to find my length, I know my width equals 5, and I know that length is 2w minus 1. So to find my length, I'm just going to plug in the width and get the length to be 9. So I've now found that my width is 5 and my length is 9. And what's my area supposed to be? 45 is 9 times 5, 45. Yep, so my solution works as a check. So notice how much work this problem was. This was one word problem. Quite a lot of thinking and quite a lot of skills we've built up in trimester 3. Distributive property, combining like terms, using the x method, then trying to figure out which solution makes sense using our zero product law, and then plugging it back into check. So these are the kinds of questions that will come up on the short answer and Regents, and it's really important to have some good practice with this. Okay? So let's take a look at exercise 2, which is another geometry problem. So this problem says a square has one side increased in length by 2 inches and an adjacent side decreased in length by 2 inches. If the resulting rectangle has an area of 60 square inches, what was the area of the original? First, draw some possible squares and rectangles to see if you can solve by guess and check. Okay, so let's just guess at this for a second. So the first thing it says that a square, so we have a square. And let's pretend, it's not a very good square, is it? Let me make a better square. Right, remember, a square has all sides the same, right? So my square should look like more like this. And let's just pretend I pick a square that's 5. I don't know if that's true, but I'm just pretending to see if I understand the problem. Now it says that it has one side increased by 2 and the other side decreased by 2. So that means my new rectangle, or my new shape, is going to have one side increased by 2, so I get 7, and the other side decreased by 2, so this should be 3. So this would be my new rectangle, right? I'm adding 2 here and I'm subtracting 2 over here. So now let's see if my area, remember the resulting area should be 60. Let's see if it is. The area is going to be 3 times 7, which gives me 21. 21 is not correct. 21 does not equal 60, so this guess is wrong. So I don't want to just keep guessing, though, with this kind of problem. I want to actually use algebra to get the answer right the first time I try it. So, using algebra, we're going to use some variables. So instead of saying 5 and 5 is my initial square over here, I'm going to say, well, let's make a square. Well, I'm really bad at drawing. This is why I don't teach geometry, because I can't draw shapes. Let's make my square, if I can draw a good square. Now let's make the sides be x and x. I don't know what the originals were, and we don't know something, we make it into variables. My new one, my new rectangle, has this side decreased and one side increased. This new one, you added 2 to this side, and this other one, you subtracted 2. So there's my new length and width for my new rectangle. Now I want my area to be 60, right? And area is the same thing as saying length times width, right? Well, if this is my length and this is my width, I can replace that in my formula and get 60 equals x plus 2, which is my length, times x minus 2, which is my width. Okay? Now let's simplify and see if we can start solving, okay? So I'm going to have 60 equals, I remember from conjugate pairs that x plus 2 times x minus 2 simplifies to x squared minus 4. Okay, that's something that, you know, when you multiply conjugate pairs, you take the square of both of them. Now I need to get, there's a trick here, and we're going to learn this a little bit later in the year, but if I try and get x by itself here and add 4 to both sides, you get 64 equals x squared. There's something very cool we're going to talk about in the next unit, where if I decide, if I take the square root of both sides, I can figure out what x is. So I'm going to do this thing right here, where if I take the square root of x squared and the square root of 64, that eliminates the squared here, and I'm just left with x. And what is the square root of 64? It is 8. So I get my answer of x equals 8. And does that check out with my original here? Right, my original area was 8 times 8 to give me 64, and so I'll call this the O original area. What's my new area? My new area would be 10 times 6 to give me 60. So my work checks out. And this skill of taking the square of both sides is something we're going to talk about later. If you had also done the x method as well here and set it equal to 0, it would have worked as well. Okay, but this is something to start thinking about as we get into Unit 13. Alright? Okay, so exercise 3, 4, and 5 involve number games. So the first exercise here is about rational numbers with certain properties. So exercise 3 says there are 2 rational numbers that have the following property. When the product means multiply, of 7 less than 3 times the number with 1 more than the number is found, it is equal to 2 less than 10 times the number. Find the 2 rational numbers that fit this description. Now this is a really heavy English problem, okay? So we really have to be careful about how we're setting up our variables. So the confusing part about this problem is this word right here. It says 2. There are 2 rational numbers that have the property. Now this property is what we're thinking about. All of these properties that these 2 numbers have. So we don't actually have we have 2 different numbers, but they share the same properties. So the first thing we're going to do is set up a variable. We're going to say let n be the numbers we're trying to find. We're not going to make 2 separate variables. We're just going to let n, because remember when we're solving quadratics, like for example, if I go back up here to this one right here, see how w came out to be 2 different numbers? Even though it was 1 variable, w had 2 different solutions. That's kind of what this problem is hinting at. We want n to be numbers. So we're going to let one variable represent possibly two numbers. And here are the following properties. Okay, so let n be the numbers we're trying to find with these properties. The first one is this property right here. That the product of, okay, so there's this thing. So we're looking at multiplication. And then we have 7 less than 3. Okay, so 7 less than 3 would be 3n minus 7. Okay, so that's the first part. Then the second part is this right here. Hold on, I got my pen. That says 1 more than the number. So there's the other part. So we have, okay, n plus 1. There's 1 more than the number. And then the last part of this word problem says equal to 2 less than 10 times the number. So 2 less than 10 times the number would be 10n minus 2. Then we have to put all of these three things together with what the symbols were in the problem. So the first thing said the product of this times the other one. So product means multiply. So I'm going to have times the first thing right here, this 3n minus 7. Then times the second part, the number with times the number with 1 more than the number, times n plus 1. Then we have this phrase that says is equal to, and then the last part, the 2 less than 10 times the number. So this is a problem that's very tricky to translate. And notice that my colors helped me. I underlined, I circled words to try and figure out the language. Okay? So with all of this done, now I can start solving. This right here, I have to do the box method for. Okay, I'm going to have to multiply these out. I get 3n minus 7 and n plus 1. I get 3n squared here, negative 7n here, 3n here, and negative 7 here. When I combine my like terms, I end up getting 3n squared plus 4n, because negative 7 plus 3 is positive 4. Sorry, negative 4. That's a negative 4. Minus 7, and then equals, I'm going to bring this 10n minus 2 down here. Okay? Now I've got to set everything equal to 0, right? I have to set this equal to 0 in order to start solving. So I'm going to start by adding the 2 to both sides. Those cancel out. I get 3n squared minus 4n minus 5 equals 10n. Then subtract the 10n on both sides. Notice I'm lining up my like terms underneath each other. So this is 0, and this simplifies to 3n squared minus 14n minus 5. Okay? Now the next step is to do the x method. So I'm going to draw my x. I'm going to multiply the negative 5 and the 3 to get negative 15, and I'm going to put the negative 14 on bottom. I can see this one pretty easily as being negative 15 and positive 1, because 15 doesn't have that many things that multiply. But I've got to remember to divide by my leading coefficient, so I divide both of these by 3. This simplifies to negative 5, and this stays 1/3. So here are the two things I'm going to put as my factors. So when I rewrite this, I get 3x plus 1 times x minus 5. Oh, not x. Sorry. We're dealing with n's. I forgot that I made n's, not x's. So 3n plus 1, n minus 5 equals 0. I set both of these equal to 0, like I did in the earlier lesson, and I'm going to end up finding my solutions to this problem. Subtract 1 on both sides. 3n equals negative 1. Divide both sides by 3, and I get n equals 1/3 as one solution, and I get as the other, add 5 to both sides, n equals 5. Okay? Alright, the last two questions involve consecutive integer problems. And we have done consecutive integer problems in the past. I believe it was in trimester 1. I can't quite remember, but I know we've worked with consecutive integers. So exercise 4 says, Find all sets of 2 consecutive integers. So the first thing I see here is, okay, I've got to define my integers. I remember from consecutive integers is I'm going to let the first integer be n, and I'm going to let the second integer be n plus 1. That's how consecutive integers work, right? The third would be n plus 2, the fourth would be n plus 3, etc., etc. Okay? Now I'm going to read how they're related, such that their product, so the product means when I multiply them, so n times n plus 1 has to equal this, 8 less than 10 times the smaller. Okay, well this one is my smaller, so 8 less than 10 times the smaller would be 10n minus 8. Okay? So now that I've set up my problem, now I multiply, set equal to 0, and I solve. So I'm going to distribute. So I'm going to distribute this right here. Distribute. I'm going to end up getting n times n is n squared, n times 1 is n. I've got to get everything equal to 0. This is really important. So I'm going to add 8 on both sides. There's no like terms with the 8, so I'm just going to bring it down. Then I'm going to subtract 10n to get that 0 that I want on the right side. I get n squared minus 9n plus 8 equals 0. Alright, now I see something very familiar, the x method. So I'm going to put the 8 up here and the negative 9 here. And negative 8 and negative 1 fit my puzzle. So I get x minus 1 times x minus 8 equals 0. And when I solve these out by themselves, x minus 1 equals 0 and x minus 8 equals 0, I get solutions of x equals a positive 1 and x equals a positive 8. Okay? Which means, though, that 1 and 8 are not my answers, right? It says find all sets of consecutive integers. So my first set is going to be 1 and 2. So there's my first set, and my second set will be 8, 9. So this is my answer, 1 and 2 and 8 and 9, not 1 and 8. So be very careful here with consecutive integers. Okay, so this is your final answer. All right. One last problem with quadratics. Okay, and this is another consecutive integer issue. So it says Brendan claims the number 5 has the property that the product of 3 less than it with 1 more than it is the same as 3 times 1 less than it, which might be the most confusing thing I've ever read, but we're going to break this down. We're going to show that Brendan's claim is true and algebraically find the other number for which it is true. Okay, so we're going to first of all translate for the number 5. Okay, so he says that the number 5 has this property. So let's start with the number 5 here. The product of 3 less than it. Anytime you see the word it, it's basically saying that 5. So 3 less than it would be what? So if we have 5 minus 3, right, that's 3 less than it. With, that means we're multiplying here, with 1 more than it, so that's 5 plus 1. Remember, we're multiplying here because we have product. Is, that's an equal sign, the same as 3 times 1 less than it. Well, here's, remember, it means 5, so 3 times 1 less than 5. Okay? Wherever you see the word it, you should think of the number 5. And let's just check and see if this is true. We're just going to check to see if it's true, that what this guy is saying works. Well, 5 minus 3 is 2. 5 plus 1 is 6. 3 times 5 minus 1 is 4. Okay, so 6 times 2 is 12, and 3 times 4 is 12. So this guy, what he's saying is true for the number 5. Okay, so let's just see if it's true for any other number, right? And we got to show this algebraically, it'll always be true. So we're just going to replace, see, remember how it said in the word problem that every time we saw the number 5, it was like seeing the word it? Well, we're just going to let n be that number 5. So wherever you see 5, we're just going to replace that with an n. So we're going to have n minus 3 times n plus 1 equals 3 times n minus 1. We're just going to replace that 5 with an n to show we have some variables, because see if there's any other number that might work with this property. Okay? So we're into the box method for this n minus 3 and n plus 1. This becomes n squared, this is minus 3n, this is n, and this is minus 3. Combine like terms here, and I end up getting n squared minus 2n minus 3 equals 3 times n minus 1. Okay, I've got to distribute the right side, so bring down the left, and I get 3n minus 3, and now of course, just like always, we've got to get this equal to 0, so I'm going to add 3 on both sides first. I get n squared minus 2n. Negative 3 plus 3 cancels out to 0, so I don't need to write anything, I'll just bring over the 3n. Subtract 3n on both sides, and I get n squared minus 5n equals 0. Now, this is not an X method problem, this is a GCF problem. So I'm going to find my GCF of both of these. This is n times n, this is 5 times n. They both have an n in common, so I get n times what's left over, n minus 5 equals 0. Now I can take both of these things and set them equal to 0. N equals 0 is one solution, and n minus 5 equals 0 is the other, so I'm going to solve by adding 5, and I get n equals 5. So what Brendan is saying works for 5, but it also works for 0. So the other number we have is 0. Okay? This lesson has a lot of, Unit 11, or sorry, a lot of Unit 12 built into it, and also a lot of Unit 10 with that X method. So take your fluency really seriously, and please ask for help if you have any questions. Good luck.